Gonna record this session now. All right, and now I'm gonna share my screen. All right, just give me a heads up once you can see this whiteboard. On the top left, I've got ungrouped data, and I've got a table with the credit card expenditure. And fantastic, thank you very much. All right, chapter and page. So we are on Learning Unit 3. In terms of what chapter, I don't really have the textbook with me right now, but Learning Unit 3 is central measures and dispersion measures. So let me just write this here. Let me see if I can get my textbook. Just give me a second. All right, got my textbook. I'll tell you now. Okay, so we're on chapter 3 of your textbook, measures of dispersion. All right, so let me just kind of write here. All right, so let's get back here. All right, so what we have here is last week, if you remember, we covered central measures. So I'm just going to write this here. Last week, oops, what's this? I'm going to take a pen. All right, so last week we covered central measures. So I'm just going to write that here. Central measures. This was last week. This week we're covering dispersion measures, as in today, this evening. Dispersion measures. All right, and both of these fall under Learning Unit 3. Okay, now for each of them, all right, so let me just remove the Learning Unit 3 so that you know that it falls there. Each of them, there's two types of data that you get for these. You get grouped and you get ungrouped. All right, it's the same thing with dispersion measures. You get grouped and ungrouped. Okay, now these we covered last week, and we're going to do this now, this evening. All right, just so we're clear on what this session is going to cover. All right, let's begin. And I'm going to use the data that you have here on the left to illustrate it. All right, so we're going to start off with ungrouped data because it is easier to work with that as opposed to group data. All right, I've noticed students tend to score better for ungrouped data versus group data. All right, but either way, you should know both, and then so you can decide for yourself if you had to choose in the exam or the assignment whether you want to do grouped or ungrouped. Then it's going to be left to you. But you do need to walk through both to decide which one you're stronger at. All right, so ungrouped data. What is ungrouped data? Ungrouped data is the data given to you explicitly, the raw data. So for instance, look at this example here. What we have here with the numbers, the 3,200, 375, or all the way to 5,400, that's basically how much someone spends on their credit card per month. So person one spends about 3,200 per month. Person 2 spends 375, or all the way to person 1, 2, 3, 4, 8. The 8th person spends about 5,400, and the values are in ascending order. I'm just going to go to the chat. Okay, not much. Basically, I'm covering dispersion measures. So I'm on Learning Unit 3, and one of the topics of Learning Unit 3 is dispersion measures, which is what I'm doing now. And I'm doing it specifically for ungrouped data. So I'm using some data here to illustrate dispersion measures for ungrouped data. So we have credit card spending for these 8 people, all right? with person 8 spending the most, 5,400, and person 2 spending second most, person 3 spending third most, etc. Okay, you won't be guaranteed that this data is given to you in order. You need to look at it, and if it's not, then you need to put it in order yourself. Okay, so just as we did for last week. All right, so that's the data, and that's basically what it tells us. All right, so one of the questions that you can get asked for ungrouped data, all right, is to work out the variance. All right, so when you need to work out the variance, you need to know which formula you're using on the right. Now, these formulas are all given to you in your formula sheet. You just need to know which formula to use to get what they're asking for. So if the question says calculate the variance, so they want to know what is the variance. Okay, then the symbol for that you'll be looking for is S squared. Now this, remember, this is just a sample, okay? This is not everyone. There's no way 8 people will represent the entire population of people using their credit card. So you'll notice that there may be 2 formulas given to you, one for S squared and one for sigma squared. This is also the variance, all right? Both of them are for variances. However, the S is for the sample variance. And often we work with samples. So when it's a sample and you work at the variance, you're going to look for the S squared symbol. However, when you're working with the entire population, then it'll be sigma squared. So you look for the formula for the sigma squared. Most times for this course, you'll be working out the variance for the sample, so it's S squared. The basic difference between the two, if you look at, let's look at the formula for S squared. You can see that there's 2 formulas, one and this one here for S squared. The one you would use for ungrouped data is this one. As long as there's no frequency in the formula or F, then you would use that for ungrouped data. Okay, so there's no F in this formula, so I'll rewrite this formula just to make it a bit neater. S squared equals a sum x squared minus n times x bar, all right, all over n minus 1. That's the formula. All right, so you don't need to memorize it. It's given to you in your formula sheet. Now you can see there's no F in this formula. So when we're working with ungrouped data, okay, you need to remember that you would use this formula where there's no F. All right. Now the basic difference between these two, S squared and sigma squared, is the denominator. That's the only difference. So when you need the variance for sigma squared, it's the exact same thing on the top. It's sum x squared minus n x bar all squared, but the denominator is just n. That's pretty much the main difference. You can see the difference is in just the denominator. It's just so you know to identify the difference, but in your case, you would be often working out the variance for the sample. So we'd only be dealing with S squared. All right. Now, before I do the whole calculation, I just want to explain to you what the variance is. Now, I know we're going to spend some time to calculate it, but what exactly does it tell us? Okay, now last week, I explained to you about a distribution, the shape. Okay, so we had a histogram, and we had the distribution shape like this. Hopefully everyone remembers this. All right. Now, sometimes you can have a distribution very similar. It's by difference here. Okay, it's more concentrated. Now, what the difference is between these two, say they both centered or they both have the average mean. Say I'll make up a value. Let's say this is 6. Let's say 60. So let's say 6,000. Okay, this one's also centered at 6,000. But you would notice the difference between the two. This one is much wider versus this one. And that's what your variance basically tells you. That's what your S squared tells you. It's telling you that this S squared, for instance, it could be 300. Sorry, 300. Let me think of that. 100, right? But this S squared for this distribution could be 50. it'll be less because it's not as spread out. You can see it's less spread out around the mean versus this one. So that's what your S squared tells you. It tells you how spread out the data is around the mean. So this one would have a higher variance. This graph would have a higher variance versus this graph. Okay, so I'm just going to pause there, just so if there's no questions about what this intuitively tells you. Okay, hopefully everyone remembers what a distribution is. I covered this last week. All right, it's the shape of how your data is. It's basically a histogram, but a smoother curve. Okay, does any questions so far? Does that make sense to you before I do the whole calculation? Anyone? Anyone lost? What if should I lose everyone? Is the audio? Okay. Thanks, Alton. Okay. So no questions so far. All right. Okay. So just keep in mind, this whole diagram that I'm showing you here, you're not tested on this. Okay. I'm just doing it so that you understand what your variance is, so you kind of have an idea what's the point of actually working it out and why this is important. Okay. Another place where variance is used is in something called confidence intervals. Now, how you would use that in the real world, think about when you buy a packet of chips, okay? Any brand, whatever. Say, I don't know what a typical size of a packet of chips is, but let's assume it's 100 grams. Okay, I'm making this up. I haven't bought a packet of chips in a while. Okay, so 100 grams is a packet of chips, right? So you got this packet of chips, and it's about 100 grams. Now, the thing is, when you buy different packets of the same chips, so say this is Lay's, whatever it is, someone else buys another packet of Lay's somewhere else in another store. All these packets will say 100 grams. But you need to understand it's very unrealistic when you put this packet on a scale that's very accurate. It's very unlikely it's going to be exactly 100 grams. Some packets maybe could be 99.995 grams. This one could be a little bit more, 1.02 grams, all right? But it's very close to 100 grams, which is why the manufacturer may be allowed to state that it's 100 grams, even though it's not exactly the same. Now, where the variance comes in is basically a manufacturer, when they're making something, like say like these packet of chips, okay, when they have an entire assembly line and they make a large volume of it, they're allowed to say it can be 100 grams, right? But it's plus or minus, let's say 5 grams, give or take 5 grams. Now this give or take value, this plus or minus 5 grams, the variance actually comes in for that. You actually need the variance to work out that error, that margin of error. We're not going to cover that in this course, but I'm just trying to show you why it's important and why we actually use this metric in practice. All right. Hopefully that gives you some sort of idea of the importance of it and why we use it. All right. If there's any questions, please give me a shout. Otherwise, I'm going to move on and we're going to go ahead and calculate this variance. All right. So I'm going to show you how to do it for both the long method and the short method. All right. So let's do the long method first. All right. And the long method basically means using this formula. Okay. But your calculator is going to do all the work for you. So just take out your calculator, please. Hopefully everyone has the Casio. So take out your Casio calculator and we're all going to work this out together. All right. So once you got your calculator out, okay, once it's on, I want you to press the mode button. So when you press the mode button, you're going to see some options. You're going to choose the stat option. If that's option number 2, then you would press 2. Okay, so you choose the stat option. All right. Then you would see another option, which is 1 minus variables. Okay, and you're going to choose that option. All right. You're going to select that option, and then everyone should have X in their calculator, and you should have a frequency column. If you were following last week, you would have set up your calculator to have this frequency column. Okay, but right now we're not going to use this frequency column. We don't need it right now, but we do need the X column. Okay, we need this column here. And now what you're going to do is you're going to capture the data here. okay, in this column. So in the first row, you're going to capture 3,200. So you would type 3,200 and hit equals to capture it, because that's the first value here. The next value is 3750. So you're going to capture all these numbers for me. Okay, and then hit equals to, and you're going to do all of these numbers, capture all of them. Once you've finished capturing up to the last number, which is 5,400, please drop me a message in the chat to say that you're done. Okay, I want to make sure that everyone's on the same page before we move on. Okay, so please go ahead with that. I think there's a couple of people already done. All right, let me see the chat. Just take everyone. That's good. Let me go back there so you can see the numbers. Okay, make sure everyone's captured all the numbers. So your last row of data, that is 5,400 sits at, would be 8. Okay, because there's 8 digits, it's 8 people. Right. All right, so once you've got those numbers captured, okay, what you can do in your calculator is you can press the on button. Okay, and just because the data has disappeared doesn't mean it has been erased. It has not. It's there. So remember, we want to get the variance, right? The variance, which is the symbol here, s squared. Okay, we're going to get the variance. So the shortcut is basically you're going to call the s, the value for s in your calculator. And how we do that is you're going to press shift, you're going to press the button 1, right? And then you should see an option that says variable, so var, short for that. Var. You're going to select that. You're going to select var, right? And then some of you, your calculator would have this here written on it, s with a subscript of x. That is the same thing as s. Okay, note that that is the same thing as s. When you select that, all right, and you press equals to, everyone should have a value of 727.7. I'm rounding to 2 decimal places, 73. Anyone didn't get that? Oh, okay. How many got that? 727.73. Fantastic. Fantastic. All right. So that's the value for S. Okay. Now note that S is your standard deviation. S is the standard deviation. Okay. And if you want S squared, all you need to do is just raise this thing to the power of 2. So if you raise this to the power of 2, then you just raise this number here to the power of 2 to get the variance. Okay, so if you want the variance, it's your standard deviation raised to the power of 2. So all you need to do is, if you still have on your calculator, let me see, raise this. If you already have that 727 on your calculator, 727.73, etc. Okay, if it's on your calculator, just press the button x to the power of 2 on your calculator. You'll see that on your calculator. If you press that, what it does is it squares this number. So if you do that, you'll get an answer of, write it in the chat to make sure that everyone's walking through this. Tell me what number you get. Then round it to 2 decimal places. Fantastic. Yes, that is it. 529.598. Yeah, that is it. Very good, everyone. So your variance is 529.598. That's your variance. Okay, that's the, so basically the way I showed you now, that's actually the shortcut. Okay, that's the shortcut. But you'll see that the long method is actually very simple. Okay, your calculator will also do the work for you for that. Right, so let's do that. Everyone's already got all the data stored in the calculator. Right, and I'm going to show you how easy it is to do it. with the long method. All right. So the long method is we're going to use the formula here. All right. We're just going to use the formula to do it instead of our calculator giving us the final answer. Now, if you look at everything in this formula, right, I'm going to break it down. Let me just circle everything in different colors so you can see it. Yeah. So we've got this term here, sum x squared. Okay. We've got this n, right? We've got this x bar, another term. And in the bottom, you just got this n minus 1, right? So the first thing we need to just get, if we're going to do it the long method, and when you do it in the long method, you need to show the examiner that you're using this formula, all right? So you need to show that you can find each of these terms in the equation. So the sum x squared, if you want that from your calculator, all you need to do is, okay, everyone can just press on in the calculator. Okay, you can, if you want the sum x squared, you press shift, press 1, and then you'll see an option that says sum. Okay, select that option for me, sum. All right, and if you select that, then everyone should see this symbol here. You should see that there, and you just select that. If it's option 1, then you select that and hit equals to. And if you do that, you will get a value. It's quite a big number. Okay, it's write down 161,682,500. If anyone didn't get that, you can let me know in the chat, but everyone should have got the same thing since we captured the same data. Fantastic. All right, very good. All right, we're all on the same page. All right. Okay, so we've got, that's our sum x squared. Okay. Okay, so write this better. Meter 1. Now the next term is n. Okay, in the equation. Now what is n? N you can get it from your calculator again. Okay, so press on, press shift, press 1. Now n is a variable. Okay, it's not a sum, so it falls under VAR. So you would choose the option VAR, and you should see n there. Okay, and if you select that, you will get a value of 8. All right, so we've got 2 of them so far. The next symbol, this we did last week, x bar, which is your average. Everyone should be comfortable with getting this if you walked through the collab last week. If you want x bar, it's the same principle. Okay, press on your calculator, press shift 1, choose the variable option, and you'll see the symbol x bar. All right, you select that, and I'll get this value. If I'll write it out for you, 4443.75. Now you've got all the values to feed into this equation. You've got everything to feed into the equation. So what I want you to do for me now is I want you to plug all these values into this equation and write the answer for me. Okay, you're going to have to put all these values into the equation and get the answer for me. Let's check the chat for any questions. Very good. All right, so I'll just keep this open. Okay, once you get the answer, please put it in the chat. So remember, this is 161,682,500. Done. No, you should get something like 529,000. Remember, your answer should correspond to what you had when you did it in the shortcut way. They both give you the same thing. They're just different ways of doing it. All right, let's see. I think everyone's entering in the calculator. All right, let's see. Hold on. So it's 161,682. Yeah. All right, let's see. Okay, let's see. Something's going off here. This is the time to sort it out. Okay, hold on. That did. Yes, but did everyone square? Oh, sorry, my bad. It's the formula. I wrote the formula wrong. Let me see why. I didn't show you that. There's a square here. X bar to the power of 2. Yeah. So your X bar must be squared. Yeah, just do it again. Sorry, yeah, that's why I didn't put the X bar squared. That's why I think everyone's getting that same answer. Yes, yes. Fantastic. Sorry, that was my fault. I didn't put the square there for the mean. Okay. Is everyone okay with this? So that's the long method to work out S squared. Okay, so basically the long method is you gotta get all these values and feed it into the equation. And the shortcut is you can just call S in your calculator. Yes, fantastic. Fantastic. Okay, I think it's 598. I think it's just a typo that you put in the chat, but you probably got the right answer on your calculator. Yes. Everyone good? Anyone, any questions or everyone's, how does this value tie in with the values in the table? Adrian. Which table, Adrian? Are you talking about the table in your calculator? Or are you talking about the data, the table that I'm showing you here on the whiteboard? The table. Oh, these, the numbers that you got here, these numbers that you got here, there's 1, there's 2, there's 3, it's all based on this, what you captured in your calculator. So everything you captured in your calculator, this all comes from it, all right? It's just that in your calculator, once you capture these numbers, you can pull this S squared from your calculator. You can just pull this value directly, right? But if you want to work it out using the long method, so using this formula here, this formula here, then you need to get each of them, and your calculator is getting all of this based on the data that you captured. And then you feed into the formula. Now you may ask, okay, why do you need to know the long method? Okay, why do you need to do this whole long method here? And the reason being is because in your exam or your assignment, if it tells you to calculate the variance and the mark scheme is 3 marks or more, if it's 3 marks or more, you need to use the long method. Okay, let me be clear on that. If it's 3 marks or more and they're asking you to work the variance out or the standard deviation, okay, because the standard deviation is simply just S, it's square root of S squared. So if you're asked to work out the variance, right, or if you're asked to work out the standard deviation, and if you see the mark scheme is more than 3 marks, you do it the long way, do it this way here, all right? But if the mark scheme is just 2 marks, all right, or less, if it's just 2 marks or less, then just do the shortcut which I showed you, which is to pull the S squared value and get S directly. Do I make myself clear on that? Is everyone, any questions on that? Do you understand what I explained? Okay, how does it build the table? I want to understand what the S squared answer means. Oh, Adrian, so that's what I explained earlier. What does the S squared tell you? Okay, so let me do it with the diagram. The distribution, yes, Kay, the distribution, very good. Yeah, so it's what I explained earlier. So remember last week, remember I explained that you get a histogram, right? Everyone should be comfortable drawing histograms now and how to get them. That's from learning unit 1. Okay, so use your histogram here. Okay, this is a rough sketch of a histogram. Now, if I take a line and I draw it touching the vertices, all right, you get something like that. So now let's just ignore the blocks, okay? Let's just say we got this, just focus on the line, right? Now you'll have a distribution like this. Now let's say this is your class, right? And the average for your scores for some course, let's say economics, right? The average was 60%, right? Let's say the average is 60%. That's your class. There's another class somewhere else, okay? And their average is also 60%, but the distribution shape is different. It's like this, very sharp, very concentrated. So yes, you both got the same average, but you can see which data is more spread out. That means you have some people who scored quite high, and you also have quite a bit of people that scored quite low. Whereas here, most of them, almost all of them, I wouldn't say all of them, but quite a lot of them scored closer to 60. So this distribution, your distribution for your class, the variance is higher. I'm going to make up this number, okay? S squared, it could be 10%. That's your variance. But for this class, your variance is 3%. It's smaller because it's showing you how spread out the data is around the mean. Here, it's a lot more spread out. This S squared is bigger, so it's a lot more spread out across the mean. Adrian, does that answer your question? How to understand what the variance is? It's basically how spread out your data is across the mean, how dispersed your data is. Adrian, does it help? No? Fantastic. All right, fantastic. Okay. Yeah, but just shout if there's any questions, please let me know. Okay, so now you know how to work with the variance. Okay, another value you could also be asked to work out is the coefficient of variation. So the CV value. Okay, you could be asked to work with coefficient of variation, which is this. Okay, and that is you're basically taking your S, your standard deviation, dividing it by X bar, and multiplying it by 100%. Right now, your S, I'll just write it out for you. Your S is 77.73, and your mean is 443.75. We worked this out earlier. 443.75. All right. So if you want to work with the coefficient of variation, you use this formula here, right? And you just plug these values into it to work it out. If you do that, I think you'll get a value of 16.38%. It's not a very complicated value to work out. Once you got your mean and you got your standard deviation, you can get it. And what it tells you, okay, so this tells you, okay, so remember that diagram I showed you before. Let's say, I'll do it here. Okay. So I remember I had this graph which is quite wide, and then you got another graph next to it, which is a lot sharper, like that. So here, this S is much smaller. Let's say this S is 3, this S is 10. All right. Now they both have the same average. Let's say they're both sitting around 60. All right, like that example I just gave you earlier. So this one, this distribution has a higher S. So when you work at the CV here, the CV here is 10 over 60. All right. And here, this CV is 3 over 60 because that's your S. Your S is the numerator and your mean is 60. So you can see that this value is a lot bigger than this CV value. So what it's telling you is what is the ratio of your standard deviation, your S, relative to the mean. The smaller that value is, then the sharper this graph is. It becomes sharper. The smaller the CV, the sharper it is. Okay, as CV increases, then it's telling you that it gets wider and wider. Okay, intuitively, that's what it means. But all you need to remember is how to work this out. Okay, you just need to know how to work out coefficient of variation, which is using this formula here. All right, that's the takeaway that I want you to kind of focus on for the coefficient of variation. All right, okay, I'm just going to erase this and then we're going to move on to another measure, which are quartiles. Okay. All right, okay, I'm done. All right, now quartiles. Now, what are quartiles? Okay, so basically quartiles is if you arrange your data in order, like what we've done here, the data is in order, right? And we want to know, okay, what credit card expenditure does, say, 25% of the population spend less than? Now, what that's saying is, here's this, let's say this is the middle, right? This is the middle of the data. At the middle point, we got 50% of people spending less than 4,500. Say that's the middle. Then we also have 50% who spend above that, since it's the middle. But let's say I want to know, okay, I want to know where 25% of them spend less than. And that's going to be somewhere around here. It's going to be somewhere around there. Okay, that's the value. Let's say this value is 3750, hypothetically. Then we're saying that 25% of the people spend less than 3750. That's what your quartiles tell you. Okay, so if you want the first quartile, then it's this. We want to know what does the first 25%. That's what quartile means. Quarter, 25%, 1/4. Okay, that's why we say 25%. Now I'm gonna show you how to work out this exact value. Okay, it's not exactly 3750, but we're gonna work this out. Okay, so let's begin calculating it. To work out the first quartile, right? Let's say they ask you to work out the first quartile, right? You first need to work out the position of the first quartile, the position, as in where would that number lie? So all these dash lines that I've drawn here, that's what you're trying to figure out. Where exactly would it sit? So the position for the first quartile, right? That formula is n plus 1 over 4. Okay, that's the formula to work out the position for the first quartile. All right. If you want, you can remember it like this. Instead of n plus 1 over 4, or you could remember it as 0.25 or 25% into n plus 1. It's the same thing, right? It's up to you how you want to remember it. Okay, but that's how you work at the first quartile position. All right, so we're working out Q1 position. So what we know is there are n data points. So your n is 8. Okay, your n is 8. So all we need to do is plug that 8 into this formula here. And if you plug that into the formula, you'll get n plus 1, which is our n is 8. So it's 8 plus 1 all over 4. And that gives you a value of 2.3. Okay, that's just the position. Okay, so that's the position. Now, what do we do with this position? Well, what this 2.3 is telling you is, if you arrange the data in order like we've done here, then this 2, let's just focus on this 2 only, right? Let's just focus on the 2. This 2 is telling you, okay, go to the second number. So there's 1, and there's the second number. Okay, so here's the second number, which is 3750. So we're going to take this 3750, all right? It's the second number. All right, now we're going to use this 0.3. Now we're going to use the decimal. We need to use the decimal part of it. So what he's saying is, it is the second number, but that 0.3 is telling us that it's a little bit in between the second and the third number. If it was exactly 2, if it was exactly just 2, then we would just take the second number, which is 3750, and we would stop here. Okay, we would just stop here. But we got a value of 2.3 that's telling us it's not exactly the second number, it's 2 and a bit. And a bit is the 0.3. And how we use that 0.3 is we take the second number, we take the 0.3, we add it, 0.3, but we multiply that 0.3 to the difference of the second and the third number. That is 4,200 minus the second number, which is 3750. All right, so that's how we use the position. If you work this out, all right, you'll get a value of 3885. 3885, and that is the first quartile. That is the answer. Okay. So what we do is this 2.3. So this 2, this means it's a second number. So that's the second number. This 0.3, okay, here the decimal part comes in here. And then we say 0.3 times the difference of the third and the third and the second number. All right. And what we're saying is, we're saying 25% of the sample spend less than 3,885. All right. Everyone, I'm just going to pause there for a second. Does everyone get that? Okay. The first step to working out the quartile position is you use this formula here. Okay. The first quartile. Once you get the position, which is what we have here, we need to use that position in this calculation. So that 2 in the position, it means we take the second number, right? Then we take the decimal part, the plus 0.3, okay? And we multiply that 0.3 to the difference of the third and the second number. Because we're saying the first quartile is somewhere between these two numbers, somewhere here. Because it's 2.3, it's not too exact. It's 2.3, so it's somewhere in between these two. And that exact value is this here, 3885. Okay, I'm going to pause there. Is that clear, everyone? How to work with the first quartile? Fantastic. All right. So just to check everyone's paying attention. Now we're going to do the third quartile. Okay, and it's very similar. It's very, very similar. Okay. If you understand the first quartile, the third quartile is very similar. Okay. Almost done. Okay. So let's do the third quartile, Q3. That's the sum of Q3. So now we work out the third quartile. Right. First thing you want to do is get the position. So we use the same formula like we did for the first quartile. Now remember, for the first quartile, it was n plus 1 over 4, right? But for the third quartile, it's 3/4. So in other words, it's 3 multiplied by that numerator and brackets, and then you divide by 4. That's the formula for the third quartile position. Or you could use this formula instead. Third quartile is 75%, 0.75 or 3/4. So 0.75 into n plus 1. You can use either one, they're both the same. Okay. So remember our n is 8, so you're going to plug in the 8 in your calculator here. And if you do that, you get a position of 6.8. Okay, now this is just the position. So we're going to do it the same way that we did for the first quartile. Okay, we use the number in front of the decimal to get the sixth number. Okay, so 1, 2, 3, 4, 5, 6. So the sixth number is 4,800. And now we use the second part, the decimal. So it's plus 0.8. And which two numbers are we going to subtract? So remember, this is the sixth number. In here, we need to subtract two numbers. That minus another number. Remember, for the first quartile, remember for the one we just did now, it was the second number, and we had plus 0.3, what we did earlier. And here, it was the third and the second. So what would these two be? Oh, people already put the numbers there. Wow. Nice work, people. Let's see. So it will be the 7th and 6th. 5,200 minus 4,800. Yes. So let's see. I think that's what you had in the chat. So it'll be 5,200 minus 4,800. Is that what you got? Good, good. Alton, I think you just skipped it by one position. But does everyone understand that? So it'll be the 7th and the 6th. Yeah, fantastic. Okay. And if you work that out, you can plug it into your calculator if you want. And the answer you should get is 5120. Very good. Very good. So here, the answer, your final answer is 5120. Okay. And how would you interpret this? Now remember, Q3 is your third quartile. So you're talking about 75% of the population. So what we're saying is, 75% of the sample spend less than 5,120 rands per month. All right. I hope that makes sense, everyone. I'm going to do one more for ungrouped data, and that is the percentile. So I'll explain what that is in a second. Now, this quartile that we did and the third quartile are pretty much percentile. That's all it is. It's just specific percentile. So what am I saying when I say a percentile? Now, what I'm saying is, when you work at the third quartile, you want to know basically what does 75% of the population spend less than. When you worked at the first quartile, it was what does 25% of the population spend less than. But sometimes you can be asked for an odd percentage. So for instance, say the examiner wants to know what is the 70th percentile. Okay, so we'll write it like this. 70th percentile is P70. Okay, what is the 70th percentile? 70. So what does 70% of the population spend less than? So what we need to do is the same principle that we just used earlier, except now the percentage is 70%. So instead of 75 here, okay, it's going to be 70. That's your position, 70. 70 into n plus 1. And if you work that out, here your position is 6.3. Now, this is your position. So what I want you to do is, I want you to give it a shot. I want you to work out the actual value. This is the position, which I've done for you. Now, what you need to do is you need to use the 6 and you need to use the 0.3. And you need to work out what is the actual number. So look at this data, what I'm showing you. I want you to work this out using the methods I showed you earlier, okay? And write an answer in the chat. Okay, so remember you're going to have to use the 6 number. You're going to have to use the 7th and the 6th number again to get the final answer. So I'll give you a minute to put that into the chat. So remember, we got a position of 6.3, so we need to take the 6th number plus this decimal part, which is 0.3, into, right, the 7th number, right, minus the 6th number. Do that. It's up to you to check where the 6th number is and where the 7th and the 6th number is. What answer do you get? Four nine. Very good. Very good, Kay. Adrian, yes, that's it. 4920. Nicely done, everyone. Yes, so the final answer that you get is 4920. All right, so you would have got the sixth number, which is 4,800 plus 0.3 into the seventh, which is 5,200 minus 4,800. And that gives you this answer here. So what we're saying here is, remember now, we worked out the 70th percentile. So we're saying that 70% of the population spend less than 4,920. Okay, make sure you write that interpretation out. Okay, you get marked for that. So it's important that you understand how to interpret it. Okay, so I'll repeat that. We're saying 70% of the population, or the sample, should I say, 70% of the sample spends less than 4,920 rands per month. Okay, all good? Everyone happy with that? Any questions? All good. All right. So that's pretty much ungrouped data. Okay. That is ungrouped data. Now we're going to do the same measures, but we're going to do it for group data. So I want to close this. No, wait, I need this open. Sorry. Same. Okay, so I'm going to erase this and I'm going to put some group data in now. This is the same data that I used last week to explain it. Let's see. Give me a second, I'll make it a bit larger. So, okay, just let me know if you can't see the table of numbers. All right, so in the first column here, this is what will be given to you. Okay, so these two columns will be given to you, what I've got in blue. All right, now I'll explain what they mean in a second. All right, in the first column, we're saying what is the grocery spending by bracket. So basically, people that spend between 0 and 400 rands in the first row. Second row is people that spend between 400 and 800 rand. In the third row is people that spend between 800 and 1,200, etc. The second column is telling you how many people do spend that amount. So in the first row, we're saying there's nobody. Frequency is 0, so 0 people spend between 0 and 400. However, there are 7 people that spend between 400 and 800 rands, etc. And then right to the bottom, we have this one person that spends between 2,000 and 2,400 rands per month. All right. Now, that's the data that will be given to you. The next two columns, the midpoints and the FX, that won't be given to you. Okay, you'll be required to work that out. All right. But now, for now, just ignore these two columns. Okay, I only want you to focus on these two columns that I have in blue. That's all I want you to focus on right now. All right. And the question asks you to work out the variance. All right. So they want you to work out the variance. All right. I'm going to show you how to do it in your calculator. As before, I'll show you the long method and the short method. So let me do the short method first. Okay, so for the variance, the symbol is s squared. Remember that. So to get s squared, now we're going to capture this data in our calculator. All right, so on your calculator, you've got new data to capture. So when you got new data, what you need to do is you need to erase the previous data. And how you do that is you press mode. Press mode in your calculator, and then you press stats, the option stat. And now you're going to be capturing a new set of data. All right. Now, after you've chosen stat, everyone should remember the next option is 1 minus var. And once you choose that, everyone should have the column X and frequency. Now the frequency column is going to play a role. So is anyone in the chat that doesn't have the frequency column? Because everyone must have that now. Last week I did show you how to set it up on your calculator. And if you don't have it, that probably means you didn't watch the collab, right? And set your calculator up. But I'm just going to assume that everyone does have frequency set up in their calculator. So that silence, I assume everyone's got it. All right. Now in the X column, that's where we're going to use the midpoints. Now I showed you last week how to get the midpoints, okay? So you're going to get this column here. To get this column here, the midpoints, all you need to do is look at your class intervals. So look at the first row, right? It goes from 0 to 400. So if you want the middle point, right, you simply just add the top value, the upper limit, 400, plus the lower limit here, add them up, 400 plus 0, and you divide both by 2, and you'll get 200. And that's how you get this value here. That's the midpoint. So for the next row, right, your upper limit here is 800, and the lower limit is 400. Okay, here, 800 and 400. Add them up, divide by 2, and you get 600. Okay, so that's how you get the midpoints. Right, so just so you know how to do it. But I've done it for you, so you don't have to do it. All right, I captured it here for you. So all you need to do in your calculator is enter the values here. So your 200 here, the next row will be 600, all the way to the last value, which is 2200. Okay, I want you to capture all of that. And in your frequency column is here. You're going to be capturing this. So make sure you capture those values. And let me know in the chat once you're done. Okay, 0, 7, all the way till 1, the last value. Okay, just give me a heads up in the chat that you finished. I'll give you just 15 seconds more. Shouldn't be too long to capture it. Oh, good. Okay. Well done. I see. All right. Everyone's got the data captured. All right. Now we want to get this variance. All right. Very, very easy shortcut method. All you need to do is press on in your calculator. All right. You can press on in your calculator. All right. What I want you to do is you're going to press, if you're going to get this S squared, you're going to press shift, then you're going to press 1, and then you're going to see the variable option, VAR. Choose that, and everyone should see this S with a subscript X. Remember, this is the same thing as S, as we explained earlier. So if you want just S, you're going to choose this option, which is my calculator option 4. All right. And if you hit equals to, that's going to, remember now, when you hit equals to, that's going to give you just the standard deviation. It's just going to give you the S value. And that value should be around 416. So you should get something like 416. But remember, this is S, not S squared. So if you want the variance, which is S squared, you just need to square this number. So if you square that number, remember, you can press this button here, X squared, on your calculator, and it'll square it for you. If you do that, you'll get a variance of, what does everyone get for the variance? Can you write it out in your chat? I want S squared. That's what I'm asking for, the variance. Yes, fantastic. Well done. Well done. 173.057.47, something like that. 47. Nicely done. So that is the shortcut. All right, that's the shortcut, everyone. And here's the long method now. The long method is also pretty simple, right? Now for the long method, we're going to use the equation. I'm going to make sure I copy the equation. I'm going to write the equation correctly this time. So it's S squared. For group data, you need to use the formula with the F in it. So it's this formula here. All right. It's S squared equals to sum F x squared minus n x bar all squared, just the x bar, divided by n minus 1. So this is the formula that will be given to you. Okay. All right. Now, the first thing, as before, I'll put it in a different color so you'll know which terms you're getting. The first term I want to get is this value here, and we're going to get this from the calculator. So this is the long method. So we're going to get each value in this equation, which is sum fx squared. Now, what I want you to know in your calculator, okay, your calculator won't give you this fx squared. your calculator will give you this instead, but it's the same thing. It's going to give you some x and x squared. There's no f in it. Just know that once you've captured the f, the frequency in your calculator, these two are the same. All right, so when you get this in your calculator, know that it is the same thing as this. All right, so if you remember how to do it, as I explained earlier, you can give it a shot now and try and pull this value from your calculator. But if you're not too comfortable as yet, I'll explain it now. What you're going to do is you're going to press Shift 1, and remember this is a sum symbol. It's a summation. So you're going to choose the option that says sum. All right, and then you'll see this in your calculator. Once you have that, write it out for me in the chat. So make sure everyone's able to pull this value. And yeah, yep. All right, very good. So you write that value out. You got that value stored. Now the next symbol in your calculator you can get is n. All right, just like before. It's exactly the same like how we did before. Your n. All right, you'll use Shift 1. Now you're going to choose the option variable. All right, variable. And if you choose that, you'll see n there. And you can just get the n value. All right, your n should be around, I think, 30. Confirm. 30, yeah. Oops. Very good. Your n is 30. And then the last thing you need for this formula is x bar, the average. And you can get that from your calculator using the same method as this. Get to variables. So you press Shift 1, and you'll see the option variables, and you'll see your x bar there. And you can write that out, which is about 1093.33. Very good. Very good. So it's 1093.33. All right. So you've got all the things you need to plug into this formula. And if you plug it all into your formula, all these values, you put it into this formula, this equation, all right, you'll get a value of 173, your s squared. Just like how you did the shortcut method, you should get a value of 173,057. 173,057. 057 point and your second decimal 47. Okay, is everyone comfortable with what you've done so far? Okay, how to work out the variance s squared for grouped and ungrouped data. Everyone's comfortable? Okay. All right. So far, we did the variance, we did the standard, and if you want the standard deviation, remember it's just taking s. So you just take the square root of it. So if you got s squared is this, if you wanted the standard deviation, you just say s equals square root of this thing here. I think everyone's okay from what I've done so far. I do want to cover quartiles and third quartiles with you. I know we're over time. Let me just get a consensus from the class. Are we okay to go for another, let's say, 15 minutes? 15, everyone? 1-5 at most. Okay. All right. Okay. Fantastic. Thanks. Okay. So let me clear this board. Okay. Now we're going to do quartiles and percentiles just like we did for ungrouped data. It's exactly the same concept. It's just the way we work it out is different. Okay. We need to work out position, and then we need to work out the value. Okay. But the way we do it for group data is slightly different. It's a lot more formula driven. Okay. And the formulas are given to you, and I'll take you through them now. All right. Let's begin. So what we want to do is we want to work at the first quartile. Right. The first quartile, Q1. That's the question. What is Q1? Okay, the first step you need to do is you need to determine what the position is. So the position, okay, Now remember, when we did ungrouped data, the formula for position was this. It was n plus 1 over 4 for the first quartile. Okay, but I know it's annoying because it's slightly different for group data. It shouldn't be, but for this course, unfortunately, it is. Okay, so you just have to unfortunately bear with us. The formula for the position for Q1 is actually n over 4. So just remember that, okay? I'm going to put a note here. For ungrouped, okay, for ungrouped, sorry, let me put it here. Sorry, grouped, it's n over 4, okay? But for ungrouped, it's n plus 1 over 4, all right? That's for Q1. For Q3, the position is 3 into n over 4. However, for ungrouped, it's 3 into n plus 1 over 4. So there's this plus 1 that's here for ungrouped, but for grouped, there's no plus 1. Okay, just remember that, okay? Don't forget that. Make a note of that somewhere, but it's very important that you remember this. So for grouped, when you're doing the position, there's no plus 1, but for ungrouped, there is a plus 1. All right, okay. So I'm going to remove this, make some space on the board. So we're going to go back to working out the first quartile. All right. So what I want you to do is we know what n is. N is 30. You worked that out earlier. Your n is 30. So just plug that into the formula, n over 4, and get the position. If you do that, all right, n over 4, which is 30 over 4, you should get a value of, this is just the position. Let's see, depends on that. All right, very good. Nice, okay. Now, remember, this is the position. Okay, now before we had the numbers. For credit card spending, we knew what the first person spent, the second person, the third person, all the way to the eighth person. We know exactly what they spent, so we can check what the seventh number is here, if we had to do the same principles here. If we had all 30 people in this table and we knew exactly what they spent, we would be able to rank them and we could pick out the seventh number. We would be able to pick the seventh number. But unfortunately, this is group data. We don't know the exact numbers, okay? Because all we have in this table is what bracket people spend, but we don't know the exact values. So for instance, look at the second row here, right? We know that seven people spend between 400 and 800, but we don't know exactly what they spend. So the best we can do is, we know this position is 7.5. So what we do is we'll round it up. So we'll make it 8. We'll make it 8. We always round up. So we'll make it 8. And what we're saying is the position for the first quartile will be the 8th person's spending if we had to rank them. So what we need to determine is, where does this 8th person lie? And this is very, very similar to what we did last week when you were doing central measures. You had to determine where would the 8th person lie. Now, if you look at the first row here, we have nobody that's here. There's nobody that's spent in 0 to 400 on groceries. So there's no way the 8th person can be there. But if you go to the second row, okay, so far we have 7 people just going to the second row because we have 0 plus 7 people so far. Why am I saying 0? Because the first row was 0, the second group was 7 people. All right, so the up to the second row, you got 0 plus 7 people, so that's 7. All right, okay. So we still under. 7 is still less than 8, so we still under. This 8th person can never be in the second interval because we only got 7 people so far. We're under. But when you get to the third row, now we have a total of 0 plus 7 plus 14 people. So that's a total of 21 people. So we exceeded the 8th person. We shot past them. So that 8th person must be in here. So this is the interval for where the first quartile person would be. This is where that person would be. This is the interval. So I'm going to mark this with a color because we're going to use this interval here to determine all the values in the formula. Let me just make sure everyone understands that. So this interval is our first quartile interval. Everyone understands that? How to get this interval for the first quartile? This is how we use this position to determine the interval. Before I move on, I just want to make sure everyone understands that. All right, fantastic. It is vitally, I can't tell you how important it is that you get this interval right. Because if you get this interval wrong, then everything that follows after this is going to be marked wrong, because the values that you use in your formula is determined by this. Okay, so the formula we're going to use is this here. I'm going to mark here. I'm going to circle it here. This formula is given to you, and all the values in this formula is determined by this interval. All right, so that's it. Make sure you get this interval correct. Now, the first value in this equation, what I've blocked out there, is 0q1, 0 subscript q1. Now, what that symbol means is what is the lower limit of this interval that we're talking about, which is here. So the lower limit is 800. You can see it here. The lower limit is 800. So I'm going to write that out. Then the next value in that equation is C. C is the class width. How wide is this class? And it's basically just the upper limit minus the lower limit, which is 400. That's your C. The next value is n over 4. All right, in that equation. And you've already done that. You've done it here. There it is. It's 7.5. All right. Then the next value that you need in this equation, just like last week, you had this symbol here, f of less than, it's all one thing. What that is, it's the frequency, the cumulative frequency before this interval. So it's all the f values before this interval added up. And in that case, it's 0. This is 0 plus 7. So that is 0 plus 7, which is just 7. And the last value that you need for this equation is in the denominator, which is f q1. And that is the frequency of your interval of interest, which is 14. That's the frequency there, 14. So you have all the values you need to plug into this equation. And if you do that, you'll get a value of, I'll tell you now, 814.29. So your answer here, the first quarter will be 814. Let me just, I'm trying to find some space to write this. Here. Okay. Your first quartile value is Q1. We worked it out to be 814.29. 814.29. Okay, that's after you plug all the values into this formula. Now, just like last week, I told you to try and sense check your answer. It's a good habit to do that. Remember, we said that this is our interval, okay? This is the interval that the first quartile will be in. So it's 800 to 1,200. So whatever answer you get, which is here, as in this case, must lie in that interval. And in this case, it does. 814 does lie in this interval. So we know that our answer is right, okay? It makes sense. And so how you interpret this? Well, what we're saying is, remember, this is the first quartile, so it's 25%. 25% of shoppers spend less than 814 Rand. Okay, that's how you interpret this. Does that make sense, everyone? Any questions? I'm going to call it there, but it's very important to understand how to work it. Okay, good. I'm very happy to hear that. Very, very happy. Nice work, people. So that's what I wanted to cover. Just remember that Q3, you can do it as an exercise, okay? I'm going to write the answer out, but it'll be nice for you to do it as an exercise. When you watch this call up again, which is what I hope you would do, you can try this out, okay? So Q3 is done in a very, very similar way, okay? You're going to use the formula. I'll show you which formula to use for Q3. Right? Q3 is this formula here. It's in your formula sheet. Okay, you'll see it in your formula sheet. Remember what you need to do. You need to work at the position. Okay, first step is work at the position. I'm just gonna write it out here. Okay, it's n over 4, but remember it's the third quarter, so it's 3n over 4. And then once you determine which interval it is, you need to figure that out, then you start using this formula here. Try that as an exercise. I'm going to write the answer out for you so you can come work towards it. Okay, so Q3, your value is 132. Oh, I'll write it out. 1320. Work towards this value here, 1320. Okay, as an exercise. And that is it from me. Are there any questions before we log off? It's all good. That's fine. When you do have questions, just give me a shout. You can drop me a mail. Let me know. Yes, do go over it again. It might be a lot to grasp in one session, but I'll make the recording available and you can watch it. You are welcome. And thanks for joining, everyone. We'll chat soon. Remember, next week is the NSS. Okay, so we won't have our collab because I think the NSS takes our slots. Okay. But all the best and have a good evening, everyone.